notes. I gotta do a little bit more before I give you this. Okay, just a little bit more. Do a worksheet, and then whatever time's left, we'll devote to review. So everybody got what they want from all this here? More than you wanted? Okay. So let me remind you what we've done so far. I'm going to put it over here. Probability of A or B was add them together, subtract both. Probability of A given B, yeah, it's probably of A and B. Right. So what would the probability of B given A be? What goes on the bottom now? A. Probability of A. But the top, notice, is still because A and B is B and A, okay? Frank and Tom. Don't you mean Tom and Frank? It's the same. Okay, I like it. Maybe. So, what's the one formula we don't have yet? We got the given. And we don't have a formula, but we do, because we know algebra. And you're like, sure. So, look at this. Probably B given A. Coming straight up. A and B. Oh my God. There we go, Jeff. Cool. Can you solve that for what you just said I'm missing? Solve it for probability of A and B. What do you do? One step. To solve it for this, what do you want to get rid of? Oh God, I thought somebody was coming in through the wall. How do you solve for this? What do you want to get rid of? And how do you get rid of this? Multiply. Because it's dividing right now. Right? So it's probability of A and B. It's equal to the probability of A times probability of B given A.
Would you also do
Yep. Maybe. I think I know where you're going.
like probability of A given B times probability of B?
Yep. That would just come off of this guy instead, right? So both of those are true. So notice this. Or, this is really, really huge. If you don't get any specifics, get this. And this is not enough, but dear God, at least get this. Or is basically add. And is basically multiply, right? Why does that make sense? If I say, all right, you guys ever applied for scholarship? Anybody ever? So back in my day, we had this giant book that sat in the financial aid office. I know nowadays we have computers and shit, but back in my day, they were just starting to come out. I'm not quite that old, but old. You had to go to the office and sit down and look, and I'd turn the page and it'd say, here's a lot of money if you are a math major and your GPA is greater than this, just barely. And. So every time they said, and then at the very bottom it said, and you are a woman. And this is actually a true story. I'm like, why don't you put that at the top so I can turn the page faster? You guys kind of with me? Now you can kind of search and shit. And is like the mean bouncer at a club, right? If I go to a club and the guy says, all right, to get in here, you got to know Joe, the bartender. I'm like, I know Joe. I've known Joe forever. Hey, Joe, hey, man. And you got to dress nice. And you got to be rich. All right, I'm out. And is the mean bouncer. And will always make the number smaller because you have to match all the requirements. Now imagine the or bouncer. The or bouncer would say, all right, you can get in the club if you're rich. Or You're dressed nice. Or, you know, I know Joe, I'm in. So the number of people that can go in the or bouncer club is much bigger than what could go in the and bouncer club. Right? In fact, and that kind of makes sense because or is add. I subtract anybody so I don't count people twice, but I am adding more possibilities. And is very restrictive. You got to do this and this. All right? That's one thing to realize. So that's going to come up a few times in the semester, just that basic idea. Here's another thing. Here's how to use this formula correctly. And what's funny is the use of it is much easier than the formula makes it look. So here's what I mean. If you live in a bad part of town, do you have just one lock on your door? No. Even if you live in a good part of town, you probably have a deadbolt and something else. But I have lived places where we had 4 locks on the door, for sure. Yeah. Those were interesting days. 4 locks on the door. Why the shit would you do that? Why would you do that? To make it harder to get in. So if there's a lock pick, he comes over and he's able to pick locks really well. I want to make his job harder, right? Not easier. So I'm going to put multiple locks. In fact, maybe multiple different locks. So I'm like, if you're going to get my house, you better be like really good at what you do, right? Or if you're going to try to wake up for a final exam, has anybody ever set the alarm on your alarm clock and your phone and told your friend to call you? Have anybody ever done that? You're like, I never thought about that. Those are all contingency plans, right? They're all like, if something fails, I've got something else to back it up. So the probability that a thief gets in should go down with more locks. So let's pretend like we know the probability of each one being picked is 1%. And actually, let's make it 10%. Let's say each one is 10%. So how does a thief get in my house through the door? Let's say all the windows are like barricaded and shit. I don't know. How does he get through the door? He's got to pick all the locks. So the probability he gets in, if I thought I add these, that immediately is stupid, right? There's no way. And by the way, what's a better way to say this? The word, not gets in, by the way. Gets in. The word all is hidden all the time. How do I get in the lock? I pick all the locks, right? Not all, but and. I pick this lock and this lock. Pick lock 1 and blah, blah, blah. Lock 2 and lock 3. You with me? So thankfully, and isn't add, right? And is multiply. So I would take, I pick the first lock. 10%, so 0.10 times the probability I picked the second lock. Times. So now what is all that going to be? These, by the way, these would be 0.01. Then these would be 0.001. And then finally the whole answer would be 0.0001. Yeah, tenths, 100,000, 10,000. So 1 out of 10,000 times somebody would get in my house. I feel pretty good about that, right? It's like, if you get in, take what you want, man. I'm impressed. I'm not even mad. No, I'm still mad. All right, maybe. So this is kind of like why it makes sense that happens. That's times. All right, I'm not going to give you that problem. I'm going to give you this kind of problem. All right, just bear with me. So I can't do cards. I'm going to just do poker chips in a bag. Sorry. 4 red, 5 blue, and 9 green poker chips. Just stay calm. I know this is a very exciting problem. Maintain calm. Just start off easy. If I pick one poker chip, let's probably get a green chip. Yeah, okay, sorry. I can't hear you. Wait. 9 out of 18. So yeah, 50%, right? There's 18 total. Are you guys with me? 18 total chips, And there's 9 chances to get what I want. So you're gonna have 50% chance of getting your green chip. I like it, I like it. So now let's up the ante here a little bit. Pick 2, and this is gonna sound very familiar, without replacement. I'm sorry, let's start off with replacement. It gets a little weirder without. What that means is I reach in, I pick 1, see what it is, and I drop it back in. And now maybe we understand better now that leaves the denominator the same, because it have the same number of chips. So what's the probability I pick a red and then a blue? All right, well, how the hell do I do this? Do you see how I just said that? A red and then a blue. So I'm going to add, or am I going to multiply? Multiply, because it's and, right? What's probably the first one is red? 4 out of 18. Put it back in. Times. What's probably the next one's blue? 5 out of 18. Is everybody with me? If I would have picked 3 chips, there would have just been 1 more link, right? You guys see that? If I would have said red, blue, green, it would have just said times 9 out of 18. So I just link, it would have been and. Those are all times.
So like with the replacement, it's just staying 18. Is that kind
So
of
with replacement is independent. Does this probability give a shit what happened here? No, because I put it back in.
Yeah, so it's the same chances.
So it's going to be dependent if I pick one and throw it away. Or feed it to my little brother. Explains why he's the way he is. Sorry, James. If you're wrong. It's like, whatever, Jeff. All right. And then what is this? Just point 0617. Gonna crowdsource that, okay. Let's do one more like this. Probability with replacement. Probably I get 2 reds. See, I mean, not only just the idea, it's very straightforward, hopefully. What would it look like?
4 out of 18 times 4 out
And then whatever that is.
4.93%.
Okay, cool.
Like it?
Okay, so let's do without.
Do you want us to keep them in decimal form or percentages?
So here's what it's going to be. All right, watch. This is the work. So if you give me a number, you don't show me this. You didn't show me work. You're going to lose points. So this is the work. This is the answer in 4 places, and then after that, I don't care what you do. You can make it a percentage if you want to. Percentages just make more sense to us, but that's the answer. And then you can make it 6.17%, whatever. Is that cool? Yes. Say again? Yeah, I got to see that, and then you can do whatever you want to with it after that. Okay. So what if I pick 2 without replacement? At least. So now let's probably get a red and then a blue. Well, on the first pick, I haven't done anything.
Yeah.
So it's probably get a red.
4 out of 18.
4 out of 18, right? Then I throw that chip away.
5 out of 17.
And my little brother catches and eats it because now he's dependent on plastic. So how many blues are in there now for the next pick?
5 out of 17.
5. And how many chips are there? 17. I love it. I love the person that puts, why do you think somebody would do this? Is wrong. Can you figure out why somebody would do that?
Oh, the chips.
They thought no, I'm picking 2 total. So at this point, I've picked 1. Things can't change by more than 1 then. I didn't suddenly lose all 4 chips. No, I only took 1 out. So now I got 17. And then I almost don't care what that is. It's whatever it is. What's probably I get a blue, what was it? A red and then a red. Now here's where things going to be. So the first one is 418 still. I throw that one away. Beautiful. One less red,
And one last chip.
one less chip. That's roughly 0.04. Is that right? That's probably not right. I did that wrong. Is it? No. Oh, 0.039, so 0.04. Yeah. 0.0392. Come on, that's pretty good. Come on. Right? No? Not close enough. Math boy. Try again. All right. Shut. All right. Good Lord, I have spoken too much. Let me give you guys this.